All right, so we're going to cover the topic RC 8 and 9, and Dr. Curtis Smith from Idaho National Laboratory is technical point of contact for this area, and I'll skip over the WRS program overview and talk about the risk-informed safety margin characterization pathway, and this is a pathway that involves developing techniques and methods to better understand the safety margin of plants, and it also uses advanced probabilistic risk assessment to optimize plant safety and performance via highly integrated simulations. So we have tools that help us do the simulations, plant simulations that can better quantify safety margin. But some of the tools we're talking about are the RELAP 7 thermal hydraulics code, Raven, which is drives the simulation and controls the simulation environment. Grizzly is a materials aging code, and it's focused right now on two particular areas: reactor pressure vessel metal degradation and concrete degradation. And then we also have some tools related to external hazards, flooding and seismic analysis tools. And so I'll turn it over to Dr. Smith.
So slide 5 has an overview of, of the RISMIC pathway. Additional details can be found in the RISMIC pathway plan that is available on the LWS website. That we have a highly integrated simulation-based approach to doing risk analysis, and one of the calls is related to how we can leverage the existing information that exists in industry, and then the second call, RC9, is related to how to optimize and enhance some of the decisions that we're making based on some of these tools. Let's go ahead and go to the next slide. RC8 is focused on really leveraging the information that exists in this industry related to the static PRA models that exist at every nuclear power plant. And one of the ideas here is how do we not only take that existing investment in probabilistic information, but how do we know when to simulate to get higher fidelity, and how do we know when not to simulate? And so the idea of a hybrid risk assessment model is really the research focus of the RC8 call. So we're looking for proposals that will explore this hybrid static versus dynamic PRA models, and leverage, again, the existing infrastructure for things like probabilities and failure rate to help us use that information, but also benchmark the more advanced models, help us validate some of these more advanced models, and also get into a little bit how these models are used on estimating things like core damage frequency, some of the importance measures for component importances, and so on. One of the outcomes would be information that we could put into this hybrid generic model related to either a P or BWR model that would be of use for the nuclear industry related to the dual nature of the static models where it's appropriate and the more advanced dynamic models where it's appropriate. So next part then is more related to management and decision making, specifically focusing on enterprise risk management and how we can look at both the economics and safety aspects of decisions. This call is going to focus on the predictive models that we have in RISMIC, and it's interesting in the sense that we have some sort of short-term kinds of predictive models related to upset conditions such as flooding, off-normal conditions, but we also have long-term predictive models that you would find in Grizzly related to plant degradation and sort of longer-term timetables of interest. And so the call would want to focus on both of those aspects. Looking at enterprise risk drivers, so for example, what the economics, how can we leverage the RISMIC information coming out of the tools, the methods, the models. Economics, of course, is a strong element of that. Examples of applications would be looking at the NEI Nuclear Promise, some of the initiatives there. Can we use RISMIC tools and methods to help support those initiatives? For example, could be looking at applications such as relaxed treatment, 10 CFR 5069, as an application of potential economics benefits related to risk informing information that comes out of advanced risk assessment. And again, more information on the tools and the overall RISMIC methodology, coupling the probabilistic and mechanistic worlds are found online in the program plan. And so with that, I'll stop and open it up for questions on either RC8 or 9.
In RC8, are you looking for better physics models for the systems? For example, CRUD development and its influence on heat transfer?
On RC8, that's looking more at leveraging the existing risk information into the simulation. So less at new physics models, unless those models were somehow built into one of the static models that we could then use in the dynamic model.
In both areas, are you interested in new efficient Monte Carlo methods to greatly reduce statistical sampling errors for RISMIC, e.g. variance reduction such as Latin hypercube sampling?
Not in this call. That would be more of an algorithm kind of development that's not part of this call.
Are you looking for industry-created models to assist in benchmarking?
Yes. In fact, the existing static models would be the industry models. And so looking for partners to help us leverage those models would be encouraged.